The formula for the area of a circle is pi r squared, or a equals pi r squared, if you want to have the a in there. So if we wanted to find the area of a circle that has a radius of 17.0 inches, well, we would just say a is equal to pi times 17.0 quantity squared. This does say to round to an appropriate number of significant digits. And I'm multiplying something with 3 digits by something else with 3 digits. That's what happens when I'm squaring it. And I'm multiplying that by something that has, well, infinite accuracy, as much accuracy as you really need. That's the pi. So going with the least one there means we're going to go with 3 significant digits. So I'll go 3.1415926, whatever. I guess I could just press the pi button on the calculator. On this calculator, you can see it's this button right here. That gives me this number. So I'll take pi times 17 squared. Or I could do 17 times 17. I'm not bothering to type in the 17.0 because that doesn't impact the numerical, the numbers at all. Rounding this to 3 significant digits, because there are 3 significant digits up here, like I said before, means I would round this to 908. This was inches times inches, so this will be 908 square inches. So if we wanted to find the area of a quarter circle, well, this is the quarter of a full circle. You know, here's if we had the full circle. The area, remember when we're talking about the area, this is the amount of space that's covered. So the area of the full circle would be all of this. But if we're talking about the area of the quarter circle, I'm just going to take and divide that total area by 4, or multiply it by 1/4 to get the area of the quarter circle. So I'm going to do 1/4 times pi r squared. Just type that into the calculator. 0.25. I could type in 1/4, but 0.25 is frankly easier. Times pi times 2.2 times 2.2. I could type in squared or just do the 2.2 multiple times there. You can see I'm choosing to do it this way. This would give me 3.802 something. Equals 3.801 rather. 13 ... I'm going to choose, this doesn't say where to round, but this number here is rounded to 2 significant digits, or it has 2 significant digits, so I'm going to round this to 2, so giving me 3.8. This is an area. We're taking millimeters times millimeters, so this is 3.8 square millimeters. If we want to find the area of the shaded region on this one, so this is kind of the area of a disk, then you'll notice, well, if we were to take this bigger circle and subtract off a smaller circle, this one in here, what would be left would be the area of this disk, and that's exactly what we're looking for. So that means I need to let me look at something really quick. Okay, yeah, good. I was just making sure that I just had a moment of, oh, did I use the diameter instead of the radius up above? On this one, remember, you need to always be using your radius. So to find the area of the bigger circle, I need to use the radius of the bigger circle. This radius right here is fortunately given to us. So the area of the big minus the area of the small, this will be pi times 7/16 squared. Not 7/17. So that's the area of the big circle. The area of the small circle is, well, I need to know what this radius is here. All I know, though, is this distance and this distance. Well, if I have that this distance is 7/16 and that this distance is 1/8, which I can call 2/16 to make sure that my units line up, because that's something you have to do with fractions, remember. Then that means this distance right here, 7/16 minus 2/16, is 5/16. That would be this distance right here, not 15/16, that's 5/16. So that means the radius of this inner circle must be 5/16. So when I go to find the area of the inner circle, this must be pi times 5/16 squared. All right, let's plug this stuff in. We'll do, you could do it in multiple steps. You could say pi times 7/16. You'll notice I'm doing the 7 divided by 16 in parentheses. I could take and figure out what the decimal representation of 7/16 is and do it that way, but I'm just typing it this way because it's fewer steps. Also, I could say I could allow my calculator to evaluate that number right there, or I could just say, okay, I'm going to take this thing and subtract off pi times 5/16 squared. And you can see I'm choosing to do it this way. I'm basically letting the calculator do all this stuff for me. So I'm not having to worry about any rounding or writing anything down midway through the problem. I have the exact answer right here. Having the pi's in there means doesn't have to be any rounding. I mean, when I say exact, the only rounding, the only loss of accuracy would be in what these measurements are. So in any case, we have pi times 7/16 squared minus pi times 5/16 squared. I press enter. I get 0.2945. Is that rounded? Yeah, that should be rounded down because the next digit is a 2. So 2945. Yeah, that's the. I was reading through this to see if there was any indication as far as where to round. I don't see any. I know the book does talk briefly about when you have a fraction, you should round to a particular place value or something like that. But I don't really. I'm not really expecting you guys to know that too incredibly much. But if we wanted to round this to 2 decimal places, 2 significant digits, 2 decimal places, they happen to be the same thing here. That would be 0.29. If we wanted to go 3 decimal places, that'd be 0.295. Yeah, whatever. That is the area of this disk.